Welcome everyone to Pure Physics. Today we are going to see example 1.6, class 12, chapter 1, electrostatics, Tamil Nadu board physics. So today's question is an important and a good application of electric field formula in this sum. So we are going to see how do we apply that electric field formula and how are we going to substitute the electrostatic force into getting the electric field formula. So we know electrostatic force formula is F vector is equal to 1 by 4 pi epsilon naught Q1 into Q2 by R square. So let me consider two charges, Q and a test charge Q0. So the distance between these two charges is R. So in the place of Q1 and Q2, I'm going to substitute Q into Q0 because I'm going to find the force experienced by this charge due to this charge. So F is equal to 1 by 4 pi epsilon naught Q into Q0 by R square. So into, I'm not going to write this vector symbol because if I write the vector symbol, I need to mention the unit vector. So I am just taking the magnitude form. So F is equal to 1 by 4 pi epsilon naught Q into Q0 by R square. So now using this equation, using this formula, I'm going to substitute in electric field form. So electric field is defined as the force experienced by a unit positive charge. Force experienced by a unit positive charge. So in the place of this F, I'm going to substitute this. So electric field is equal to 1 by 4 pi epsilon naught Q into Q0 by Q0 R square. So this Q0 will get cancelled, and I know this 1 by 4 pi epsilon naught as K. So if E vector is equal to, and when I write vector symbol, unit vector is very important, and E vector is equal to K into Q by R square R cap. So in the magnitude form, I can write, here I cannot mention magnitude. In magnitude form, I can write K into Q by R square. I should not mention the unit vector. So this formula I'm going to use to get the answers for these two questions. So now let us move on to the diagram. The diagram has been given in the question. So we have two example graphs in which in one graph the source charge is positive and in another graph the source charge is negative. We have first graph. Let us see the first graph. At the first graph, the source charge is positive and it is kept at origin. From origin, that is from the source charge, at a distance of 2 meters, we have a point P. And from the source charge or from the origin, at a distance of 4 meters, we have a point Q. So now we need to find the electric field at a point P as well as at point Q. So I'm going to use this formula. For first case, I'm going to solve using two sub cases. So I'm going to write this formula which is for electric field. E vector is equal to K into Q by R square into R cap. So when I'm writing the magnitude form, I don't need this unit vector. So for point P, I'm going to write for point P. See, here the distance between the source charge and point P is 2 meters. So I can use R is equal to 2 meters. R is equal to 2 and Q is nothing but the charge. The charge is given as 1 micro coulomb, which is nothing but 1 into 10 power minus 6 coulomb. And we know that K value is equal to 9 into 10 power 9 Newton meter square coulomb power minus 2. So I'm just going to substitute these given data into this equation. Modulus, that is E is equal to 9 into 10 power 9 into 1 into 10 power minus 6. If I take modulus on this E vector, then I need to take modulus on this. If the answer of this expression comes negative, then taking modulus of that expression, I will get positive, which I will see in the second part of the question. So in the first part, we don't see like that. So E is equal to divided by 4. R is 2 and R square is 4. So 9 by 4 into 10 power 9 into 10 power minus 6 is a power m into a power n, which is a power m plus n. When I add 9 and minus 6, I'm getting into 10 power 3. So E is Newton coulomb power minus 1. So E is equal to 9 by 4. I'm going to divide 9 by 4. 2, 8, 1, 10. Again, point. I'm going to take point and I'm going to take 0 here. 2, 8, 2, 20. I'm going to take another point. 0. 2.25. So when I divide 9 by 4, I'm getting 2.25 into 10 power 3 Newton coulomb power minus 1. So when I write it in the form of electric field vector, E vector is equal to 2.25 into 10 power 3 I cap. Why I am choosing I cap? Because It is in positive x-axis. So when I write in positive x-axis, it is I cap, positive I cap. So I write positive I cap, Newton Coulomb power -1. So this is in the form of vector and this is the form of magnitude. So now let us see for point Q. So for point Q, so point Q, now I have the given data as R is equal to 4 meter because from the positive charge it is 4 meter. So I write R is equal to 4 meter. Charge is same 1 microcoulomb. So charge I will write it as 1 into 10 power -6 coulomb, and I'll write the K value as 9 into 10 power 9. So now I'll write in the formula model E is equal to 9 into 10 power 9 into 1 into 10 power -6 by 4 square is nothing but 4 square is equal to 16. So in the place of 4 square I'm going to write 16. E is equal to 9 by 16. 9 by 16. Right, 9 by 16 into 10 power 3 Newton Coulomb power -1. So 9 divided 9 is being divided by 16. So 16 is obviously we can take 0 and write 0 here. 9 we can take point division will come 90. 16 6R is 96R. 16 6R 36. Yeah, 96. 16 6R is 96. So it is impossible to take 16 6R. So 16 5R, which is 80. This is 80 and it will give you 10. And obviously you're going to take another 0 and you'll take again 100. Now you can take 16 6R, which is 0.56. So I can use E is equal to 0.56 into 10 power 3 Newton Coulomb power -1. And now here I'm going to use in vector form. When I write in vector form, I get 0.56 J cap. 0.56 into 10 power +3 J cap. Why I'm taking in J cap? Because it is in positive y direction, which represents plus J cap. Newton Coulomb power -1, which is the unit. This is in electric vector form, electric field in vector form, and this is electric field in magnitude form. So let me go into the second question. Now the answer is for this second question or the second graph. So in the second graph, what we see is this origin. In the origin, we have a negative source charge, and at a distance of 2 meters from the source, we have a point P. And from a distance of negative charge, distance of 6 meters, we have a point Q in the negative x-axis. And now I'm going to just find for P. Here for point P. Here for point P. For point P, I'm going to use the distance R is equal to 2 meter. Charge, now the charge is -2 microcoulomb, which is -2 into 10 power -6 coulomb, and K is equal to 9 into 10 power 9 Newton meter square Coulomb power -1. This is the value. So I'm just going to substitute in the magnitude form. So now first, before writing in magnitude form, let me write in electric form, which is equal to 9 into 10 power 9 into -2 into 10 power -6 divided by the distance is 2 meter. 2 meter means 4. 2 square is 4. So now if I multiply 9 into -2, I get -18. As a result, the whole electric field vector will be in the negative answer, right? Negative answer. So in order to restrict that, since I'm going to use magnitude form, I'm going to take modulus on both the sides. So whatever answer I'm getting in negative, it will become positive when I take it out of modulus. So it will become E is equal to 9 into 2 is 9 minus 2 is -18. When it comes out, you get plus 18 into 10 power 3 by 4. So 18 by 4 is easy, which is 9 by 2. 9 by 2, you get 9 by 2, 9, and this is 2. So when you divide 9 by 2, 2 4s are 8, which is 1, 10, 4.5. This is 4.5. E is equal to 4.5 into 10 power 3 into 10 power 3 Newton per Coulomb. It is in magnitude form. If I write in vector form, then you need to understand the source charge is negative, and the electric field is always towards the negative charge. So it will be in the negative x-axis. It will travel along negative x-axis. So we need to give E vector is equal to 4.5 into 10 power 3 minus I cap because it is in the negative x-axis. So minus I cap Newton per Coulomb. So electric field final answer will be minus 4.5 into 10 power 3 Newton Coulomb power -1. So this is the electric field form, and this is the electric field vector, and this is the magnitude form. Now for point Q, we are going to use. Now for point Q, we're going to take R is equal to 6 meter because the distance from the negative charge to the point Q is 6 meter. So I'm going to take for point Q, I'm going to take the distance R is equal to 6 meter, Q is equal to minus 2 into 10 power minus 6 coulomb, and K is equal to 9 into 10 power 9. Okay, Newton meter square coulomb power minus 2. So now I'm going to just substitute in this equation. First I write in E vector. E vector is equal to 6 into, 9 into 10 power 9 into minus 2 into 10 power minus 6 divided by 6 square is nothing but 36. Now I'm going to take modulus. Whatever answer I get in minus here will become positive. So E is equal to 18 by 36 into 10 power 10 power 3 Newton per coulomb. So when I divide 18 by 36, it is 1 and it is 2. 1 by 2 is equal to 0.5. So the magnitude form of electric field is nothing but for point Q is 0.5 into 10 power 3 Newton coulomb power minus 1. So if I'm going to write in vector form, then absolutely I need to write E vector is equal to 0.5. Since the source charge is negative, the electric field from Q point will be towards the source charge because electric field are always directed towards the negative charge. So I'm going to write electric field vector is equal to, so this will travel in positive x-axis. It will go in this direction, which is positive x-axis. So when we represent positive x-axis, the unit vector will be positive I cap. So when I write this 0.5 into 10 power 3 plus I cap into Newton per coulomb. E vector is equal to plus 0.5 into 10 power 3 Newton per coulomb. So this is your answer for the second subdivision, point Q. So we have solved for the first subdivision for point Q and for point P, and for subdivision 2 also we have solved point Q and for point P. So this is the basic and easiest question if you have to attend this question in your examination. So let us see in the next video for example 1.1, which is the basic of this chapter and is the easiest question of all. Thank you.